We're showcasing how browser and mobile client applications can fetch their configuration settings from Azure App Configuration through Azure Front Door. This lets the clients access configuration anonymously while still keeping everything secure and scalable. Here's how the flow works. The client application sends a request to an Azure Front Door endpoint. This endpoint is configured with Azure App Configuration as its origin. Azure Front Door uses its managed identity to authenticate to the App Configuration Store. App Configuration returns the configuration values and feature flags, and Front Door sends the response back to the client. This means we automatically benefit from Front Door's caching, global distribution, and performance optimizations. Now let's move to the Azure portal to see how this integration is set up. I'm starting in a new App Configuration Store. Under Settings, I select Azure Front Door. This is the new blade used to configure the integration. I can either select an existing front door or create a new one. For this demo, I'm creating a new front door profile. I've entered a profile name, an endpoint name, chosen a system-assigned managed identity so Front Door can access the store, set caching to 5 minutes, and added a scoping rule so only key values that start with .appconfig.featureflag are exposed. I can choose either the key value filter or the snapshot filter to scope the requests. Snapshot filters will be great for assuring consistency of settings, as snapshots are immutable. When I click Create and Connect, Azure deploys an ARM template that builds the front door profile, the endpoint, the origin group, and the routes with the scoping rules I selected. Now let's look at an existing store where Front Door is already connected. Here, I can either create new endpoints or disconnect from the current front door. If I open the front door, I can view all endpoints associated with this front door profile. Next, let's switch to the client application to see how it consumes configuration through Front Door. This is a JavaScript application. In the configuration provider, the application loads configuration by calling the front door endpoint, not the app configuration store directly. Feature flags are enabled, and the front door endpoint URL is set in the config file. Let's build and run the application. On the home page, the app calls the feature manager to get the variant for the feature flag named OpenAI New Model, passing the current user details and targeting context. Based on the variant returned on or off, the app chooses whether to use GPT-4 or GPT-5 for the chat model. The feature flag has 2 variants, off and on, with a 50 to 50% rollout. There's also an override rule, so the admin user always gets the on variant. Telemetry is enabled, so we can track evaluations. Running the application, the default user sees GPT 4.0. In the network trace, we can see the call going to the front door endpoint, retrieving both key values and feature flags. When logged in as admin, the app correctly shows GPT 5.0 from the on variant. Let's ask the model a question about app configuration. Then we create 2 new users to check the percentage rollout. One user receives GPT 5.0, and the other receives GPT 4.0, confirming that the 50-50 allocation is working. The app also sends custom telemetry for interactions. Here, if a user clicks the like button on a response, that event is sent to Application Insights. In App Insights, under Custom Events table, we can see feature flag evaluation events, business events, and user interaction events. This helps us analyze how each variant is performing. Running this custom query shows that users receiving newer model like the responses way more than the users on older model. Based on this analysis, now we can safely roll out new model for 100% of our users. This concludes our demo on how client applications can securely fetch their settings from Azure App Configuration through Azure Front Door and use feature flags and telemetry to run A/B tests, providing valuable insights into feature behavior and user interactions for their applications.